Thank you very much for attending our session part. And I am Hironori Nakano from Softbank, Director and Solution Service First Department. And in this session, two speakers will speak. And second speaker is Someya-san. He is SDN architect. This is agenda today's. Firstly, I will speak introduction of SoftBank and data network businesses. And second, I will speak SoftBank SDN business overview. And speaker Someya will speak SDN NFV tech details. The first introduction of SoftBank data network businesses. And first, Softbank Group. Softbank Group is a holding company, and CEO is Masayoshi Son. And consolidated sales is 9.6 trillion Japanese yen. That means about 96 billion US dollars. And Softbank Group, as I said, a holding company. So this has many subsidiaries like this. And actually we are belonging to Softbank KK, Softbank Japan, written in blue box. And we are belonging to the enterprise business unit. And Softbank Group has also other companies, subsidiaries like Sprint, Yahoo Japan, and ARM, and Softbank Vision Fund, and so on. So I'm belonging to the enterprise business unit, and this mission is to innovate customers' business and societies with cutting-edge technologies. So we have a lot of services like these mobile fixed line phone services, and data network services, and cloud and security services, and we are our department working for this area. And other services, digital marketing and AI and robotics and IoT services and so on. So next, let me explain about SoftBank enterprise network businesses. SoftBank is a Japanese telco, so data network business is a major product and services that is called smart VPN services. That is based on MPLS technologies to provide private network for our enterprise customers. And actually, I'm not in charge of core network services. Actually, I'm in charge of value-added services written in blue, like remote access gateway through internet and pure 4G LTE network, and internet access gateway services, firewall and proxy and so on. And we have my department have a lot of security products and authentication services, and security monitoring services, and so on. And let me explain our gateway services in detail. And we call it white label gateway services, and we operate our equipment in our data center and between MPLS network and internet or 4G LTE network equipment. We are providing a lot of services like SSVPN, which is leveraging Cisco SA, and UTM services, and load balancer services, and mobile core IP gateway services, and web security services, web filtering and proxy, and so on, and mail security services, and server security server services, and so on. And in addition to that, we are providing managed security services to monitor our firewall and so on. And we are providing this kind of services on physical server or virtual server and physical network appliance. And customer can choose. And before SDN, we had some challenges like this. First one is long delivery time. We needed to deploy services for 1 month. It's a very long. It was a very long time, and we needed to take a few days to change a setting from customer demand. And second one is operators workload continued to increase as we got a new contract from customers. Because deployment was by hand manual, so it was it was not efficient. And third one, the capital context issue continued to increase as we got a new contract. And so to overcome these some challenges, we tried to introduce new SDN infrastructure to our gateway service environment. And then we, at February 2016, we successfully launched SDN-based white cloud gateway services. And this slide shows you our overview of Softbank SDN architecture. In middle, you can see NSO with service model. And thanks to the Cisco team and data data team, we could develop a SaaS model to deploy and to run very complex services on our gateway equipment. On top of that, we have a portal. Smart VPN Web is a customer portal. Actually, we developed this portal entirely by our IT team. And thanks to our NSO and Smart VPN Web portal, our gateway service operator can deploy PNF or PNF setting through this equipment. And next, our SDN business overview. And as I said, we launched to 2016 our SDN-based gateway services, and we started two projects. And first one was mobile core virtualization, and second one was version up tasks, and that include minor version up and major version up. Both projects took about 2 years, including SaaS planning and financing tasks and so on. The first project is mobile core virtualization. We had, of course, gateway services, but it was very poor function, so we needed to improve these services. So we developed new gateway services, and customer can enjoy full edge architecture and scalable system with leveraging virtualization function. And customer can use a custom portal to change the setting on gateway. And customer can enjoy a lot of merit with these new services. And in use case, NSO is used for configuration of router between MPSPE and gateway. And this slide shows you our NSO use case with sort of virtual gateway. In use case, I explain how NSO work in this use case environment. And first, if customer want to change pool address for devices on P gateway, this firewall and router have to have routing information to go up to the P gateway. So in this case, NSO has to put routing information to existing firewall and router to go up to the P gateway. In this use case, we have many customers, like connected car deal, maximum 2 million subscriber connected car deal, and we have smart meter deal for electricity charge. And we have also PC or smart devices, internet access with fixed source public IP on firewall here. And second project is version up from NCS to NSO. Actually, we major version up from NCS to NSO. We took 1 year for migration from NCS to NSO. The method is there. We had the old NCS infrastructure here, and in parallel, we developed new NSO environment here, and then we switched from old environment to the new NSO infrastructure to call API from Smart Gateway portal. So in this project, we took big challenges. Like that means a long-term development issue. As I said, we took 1 year over and so on. So that was very long time. It's too much long time. So we needed to shorten this time for new size development and so on. And the second speaker, Someya, will explain this solution later. And this slide shows you our transition to SDN infrastructure after SDN service launch. As I said, we launched SDN-based gateway services, and here April 16. And then we have continuously new customer like these, and now we have about 40% SDN customer. That is a ratio on the total number of gateway customers in Softbank. And we aim to exceed 60% SDN ratio by the end of fiscal year 2020. And next development here, we aim to develop security automation and cloud connection and wide bandwidth. First is MSS integration. And we have existing SIM infrastructure in our environment, service environment. And as you know, SIM has a lot of load. In this case, SIM has a load from firewall and gateway equipment from via SQL server, and SIM has a load endpoint service load, and SIM has threat intelligence information from these APs. So if SIM detect a security event, and then SIM can put and add a blacklist through a NSO to a customer's firewall. This is the first, integration point. And second one is cloud connectivity. As you know, our customer demand to connect major cloud and Zscaler as a cloud proxy and so on. And customer want to connect private access to major cloud and Zscaler. So we will add IPsec and GRE connect function to existing firewall services. That means we need to change NSO service model. That's the next second development. And third one is wide bandwidth. As you know, of course, as our customer want big wide bandwidth due to the big traffic through to Office 365 and G Suite and other SaaS and so on. So we need to support wide bandwidth firewall services and up to 10 gig BPS and so on. And that also mean we need change NSO service model, but it will be a very easy change, I think. That is our part, and next Someya will speak tech detail.
Thank you. Hello everyone. Welcome to my presentation. My name is Kentaro Someya. I'm in charge of developing Orchestrator and this platform for gateway service. The purpose of today's presentation is to introduce our service and the recent approaches. Let me start by briefly introducing our gateway service. We provide the secure gateway between networks with firewall and remote access VPN. Each segment can deploy various service components such as NAT firewall, load balancer, GSLB, IaaS, FastSaaS, and so on. These gateways are located in Osaka and Tokyo sites as a same topology. To deliver the network service quickly, we are also providing NFV service. On the other hand, if a customer wants to use high-performance device, we can provide a physical device. All customers can use any service component when you want to use. Because it can be used any service components, these network structure are very, very complex. Of course, these devices become each different configurations per multi-vendor. We had configured all devices manually via SSH command before using Orchestrator. Our engineers were tired of such situation. In order to solve such problem, we adopted NSO and VTS in 2016. NSO can configure the unified configuration as NSO service model without being considering of multi-vendor configurations. As a result, almost network network devices are managed in NSO. We become to configure to only NSO. Thanks to using Orchestrator, we can easily become to configure, become to create service network for the customer. The deploy time has become 1/3 compared to before using orchestrators. Next, we explain the software-defined architecture of our gateway. NSO, we can possible to provide physical and virtual devices to meet customer requirements. Each physical devices are connected to a Nexus switch, and VNFs are deployed on VMware ESXi. For example, if a customer wants to use firewall, load balancer, and proxy service, we prepare corresponding service components in our data center. For each segment, these provided devices are connected via VXLAN and VLAN. These configurations to Nexus switches are performed with SDN controller, so-called Cisco VTS. In addition, vCenter port group with the specific VLAN corresponded to the customer network are created by vCenter with VTS plugin automatically. And the virtual machine is powered on automatically too. In this process, we can create the customer network from NSO via VTS NADO without logging into Nexus switches or vCenter and so on. Only NSO. At this time, it is not set to firewall and load balancer yet. NSO configure such device per customer requirements. Finally, we provide a customer portal, so-called Smart VPN Web, and deliver the service to the customer. This portal calls the northbound API of NSO to change customer configurations such as firewall policy, NAT, and so on by customers themselves. Now, the API access exceeds about a few thousand per month to NSO. To 3 years summary. We manage about 500 devices, which are different each in NSO. By providing NFV service, about 70% devices are provided virtual appliance, thanks to very short delivery time. API access from our customer portal to NSO exceeds a few thousand per month. That delivery time has become 1/3 to before using Orchestrator. But the difficult point is NSO operations for us. This figure is the deploy time of the very simple network configurations. We have been using from NCS, but the deploy time was gradually increased, and the software UL requires a version upgrade. We have performed major upgrade twice so far. In the service lifecycle, testing was the most time-consuming part. We took time 6 months of testing time in recently major upgrade project because of all manually. In addition, tests are often required to modify bugs and to release new service. Moreover, recently network virtualization has advanced and its operation have become difficult. Therefore, we needed to automate test and operation. We introduced part of the automation test system with Jenkins and Python via NSO, VPS, and the other device API as a recent approach. Because almost devices have itself APIs or NSO-net API, we can easily create Python code with several Python packages, for example, JSON and requests module. This figure is This figure is a Jenkins pipeline process. In this process, a virtual machine is powered on, got the configurations, and create service automatically. Almost test process became automatically. The test time went from 6 months to about 1 month. Thanks to test automation, the free time can be used for development. Next approach, we are considering operation automation. Still in development, but for example, in the case of major failure, there will be a lot of alarm. It is difficult to identify the failure point in a lot of alarm quickly. We developed code to predict failure point with SDN NFV trap and Cisco VTS. Cisco VTS has all physical and virtual network topologies, so such code can easily create with VTS API. Finally, future plan. We are testing connection of major public clouds and SD1 via IPsec VPN. On the other hand, we are also developing a security service which will automatically close the firewall policy via NSO API if there is a security incident. Moreover, to manage service lifecycle, we will consider NFV lifecycle manager such as Cisco ESC. Conclusion. A network orchestrator has shorter deploy time than manual. On the other hand, testing time to release will increase and it will be difficult to operate. As a result, it takes longer to release the service. So automation is important to make the service lifecycle fast and stable. We will continue to promote service lifecycle automation. Thank you.
Okay, any questions? We'll have the hand mics here. My question down there.
Hello, Laurent. I have from Orange France. I have two questions. First question: today, what is the ratio? What ratio do you have between manual testing and automation testing? First question. And second question: when you develop code, how do you systematically develop the automated script accordingly?
Time ratio?
But it's a ratio between manual testing, because I believe you still have manual testing as you test during 1 month. About. So I was wondering if the ratio of automatic testing was increasing during. What's your objective? Is your objective to have 100% of automated testing?
Automation test item is 1,000 items.
1,000 tests
Yes.
are automated?
Yes.
Okay.
Manually is maybe 100 items. Almost test item is automatic.
Thank you.
Hello. You have mentioned you took around 1 year time to migrate from NCS to NSO. What were the major challenges which you faced and why it took 1 year time?
Your question is why we take 1 year to migrate?
That's right. And what were the major challenges you have faced during that time?
So we think what the challenge to
No, basically why it took 1 year time. The
yeah,
migration.
migration.
So in the major progress project, test time is 6 months, and we change no smart API to smart VPN web. So the change no smart API. So development of smart VP, development of web is become difficult. Yeah.
Thank you. So if you're planning to, let's say, move from 4.5 to a future version, you're anticipating that it will take shorter time in the future. Yes, maybe in future progress to over 3 months.
We had NSO 5. We had the migration from NSO 4 to NSO 5 easier compared with NCS to NSO 4. So we expect a very short time.
Yeah, thank you.
I had 2 questions. Hi, I'm here. Actually, I'm here. Actually, I have 2 questions. One question is concerning your team. Were you developers, network engineers? How if you could give us a feedback on how your team compositions evaluates with the time. I'm not sure I'm clear, but how your teams, because you seems to use NSO for a long time and for many projects, so how your team group, it would be interesting for me to hear your experience.
So your question is about development team or component IT, how many IT admin guys and how many network guys and so on. Okay. So we have what's the same? And we have a IaaS team, and that includes virtualization guy, server virtualization guy, and network infrastructure guy. And that ratio is 1:1, the same, our same. And we have IT guys in other team. Probably the number is same. So IT and virtualization team and network team are same ratio.
And how many in total? How big is the team?
So about 10.
You described a bunch of operational difficulties when you moved to the new system. Can you describe what some of the issues were?
Sorry, we could speak.
You had a bunch of operational considerations that made the using the software increased the time or the difficulty of what sort of operations?
Operation cost. それは時間がかかるととりあえず時間
Operation time is not increased after using Orchestrator.
Described it as going from easy to difficult.
So the difference is if there is a big failure, outage. So the failure point is we don't know failure point quickly. So with the orchestrator, sorry.
You mentioned.
Yeah. The network operator no good. Network operator no good. Orchestrator. Yeah.
Okay.
Cisco, the bridge to possible.